Hello and welcome once again to BYJU'S classes. My name is Atiullah and we are live again with yet another session, this time on pre-board mock paper discussion for physics. So before we begin this session, just let me know if I'm audible, let me know if you can see me clearly. Alright, just give me a thumbs up, give me a yes so that I know that I am clearly audible and visible and we can get going with the session. Okay, how are you guys doing? Abhijit asks, Kem cho? Abhijit, Majama, how's it going for you? Festival season around the corner. Are you guys excited for Diwali? I'm very excited for Diwali. I have a lot of plans. I have a holiday. We are going to have fun. I think both of us, all of us, are going to have good fun on Diwali. Yogesh, good evening. How are you? All right, I'm audible. So I think we are good to go. Alright, so we are here for a pre-board mock paper discussion for physics. 1 month term 1. Okay, no, exams will, Yogesh, exams will come and go. Not to worry, but sometimes you need to take some time off. You need to recharge yourself. So festivals are a good time to do that. So do enjoy yourself on a festival. Alright, yes, definitely we are going to start this session. Alright, so I hope you guys have taken your mock test. You guys have tried to analyze your mock test. You would have got your scores maybe. So this session is about discussing all the questions, where you could solve the question in a quicker time. Where did you make some conceptual mistake? Where did you make some calculation errors? We want to discuss all of that so that you have a good understanding of how your preparation is. Alright. So let's get started. So just a brief reminder of the pattern. I think you guys are well versed with the pattern now, but just a quick reminder. So the question paper, it's for 90 minutes. The maximum marks is 35 and it is divided into 3 sections. Section A, we have to attempt 20 out of 25 questions. Section B, we have to attempt 20 out of 24 questions, and in section C we have to attempt 5 out of 6 questions. All questions carry equal marks and there is no negative marking. So I genuinely hope that nobody has over attempted the questions. Alright, Reshma is asking, sir, kaun sa topic hai? So there was a mock test paper and we are going to discuss the test paper for we are going to discuss physics section for that mock test paper. That's what this session is all about. Okay, Anshuman says, I got AIR 13 in NEET exam. Anshuman, congratulations. That's a great rank. Many congratulations. So yeah, keep that up and all the best for your future endeavors. Alright, so without wasting much time, let's get right into it. But before that, let me just talk about 2 things. First, in this session, in the interest of time, because we have to solve so many questions, I'm not going to get into the calculation. You guys are smart enough to figure that by yourself. And secondly, if questions are very simple, if they're formula based, then I'm not going to spend much time on it, so that we can spend more time on things which are more concept intensive. Okay, so let's get cracking with this session. Okay, so we are dealing with section A. What is the first question? Which of the following is a property of equipotential surfaces? Option A, the direction of electrostatic field will be perpendicular to the equipotential surface. Option B, the potential difference between any 2 points on an equipotential surface is 0. Option C, for a point charge, the equipotential surfaces will be concentric spheres. All of the above statements. Alright, so let's see. So the change in potential is given by integral of E dot dr. If we are moving on the equipotential surface, so potential of all the points are same, so delta V will become 0. If delta V is 0, then from this equation we can see that E and dr have to be perpendicular. Alright, then for a point charge, the direction of electric field is going to be radial. So the surface which is going to be perpendicular to all these electric field lines is going to be concentric sphere. So what will be the correct option? Option D is going to be the correct option, and I hope most of you would have got that right. Next one. For which of the circuit diagram, what is the equivalent capacitance between points A and B? Alright, this question is a sitter. I am assuming that everyone would have done this question right. So if this is point A, this is also going to be point A. If this is point B, then this is also going to be point B. So we can see, I'm sorry, this, if this is point A, then this is going to be point A, and if this is point B, then this is going to be point B. So we can see that all the capacitors are between points A and B, hence the combination is parallel. So we'll simply add the capacitance and we'll get 9 microfarad as the answer. Option A will be the correct option. Let's go. An electric dipole of dipole moment P is placed parallel to the uniform electric field of magnitude E. The amount of work done in slowly rotating the dipole by 60 degrees. So the dipole now would be like this. We have to calculate what is the work done. Now the potential energy is given as minus P dot E. The work done will be equal to the change in potential energy. So this will be minus PE cos theta 2 minus PE cos theta 1, which will be PE cos theta 1 minus cos theta 2. Now what is theta 1? Theta 1 is going to be 0 degree, and what is theta 2? Theta 2 is going to be 60 degree. We substitute, we get PE by 2 as our answer, and hence option D is going to be the correct option. And I can see most of you are getting that right. That's amazing. Next, a parallel plate capacitor is charged with a battery of EMF V volts. After charging, the battery is disconnected and the distance between the plates is increased to 1.5 times. The new potential across the plates of the capacitor will be. Alright, let's solve this. Now the capacitance for a parallel plate capacitor is given as A epsilon naught by D, and C we can also write it as Q upon V. Is that correct? So from here we get V is equal to D upon A epsilon naught into Q. Now we have removed the battery and we have increased the distance between the capacitor, so the capacitance is going to change. So the new capacitance C prime is going to be A epsilon naught upon D prime, and what is D prime? It is 1.5 D, and this we are going to write it as Q upon V prime. Notice now this is an isolated capacitor, so the charge is going to remain the same. The potential is going to change, which is going to become V prime. So V prime is going to be 1.5 multiplied by this quantity, which is nothing but V. We have already calculated that. So the answer is going to be 1.5 volt, and option C is going to be the right option. Alright, pretty straightforward. The dimensional formula of capacitance is, okay, these questions are sitters, they are so simple. Capacitance is given by Q by V. So I'm going to do a smart thing, I'm going to multiply and divide it by Q. So this becomes Q square upon V into Q. QV will have the dimension of energy or work. So for charge, we are going to write A into T, ampere and time. So the square of that, and then divided by MLT minus 2 is going to be force, multiplied by L is going to be work. Alright, so this will be my answer. Pretty straightforward. Option D is going to be the correct option. Next, the graph between magnitude of electric field intensity due to a positive point charge as a function of inverse of distance from it is. Okay, so we have to find out the electric field as a function of inverse of distance. Okay, let's see. So the electric field is given by KQ by R square, but here what is our variable? Our variable is 1 by R. It is not R. The variable is 1 by R. So 1 by R, we can take it as a separate variable. Let's say it's X. Okay, let's take it's a separate variable. So this is going to become E is equal to K into X square. So if you're plotting E and X, then this graph is going to be a graph of a parabola. It's like a quadratic expression. Okay, so the graph is going to be a parabola. So option C is going to be the correct option. What is next? The maximum torque that a dipole of dipole moment this would experience in a uniform electric field of magnitude 4 Newton per Coulomb. Okay, so what is the dipole? What is the torque on a dipole? The torque on a dipole is P cross E, which is going to become PE sin theta, the magnitude. And when is it going to be maximum? It is going to be maximum when theta is 90 degree. So maximum torque is simply going to become P into E. And we substitute the value of P and E and we get the answer. So what will be the correct option? Option B in this case is going to be the correct option. Next, In the following network of wires, the value of current I is, okay. So what are we going to apply here? We are going to apply obviously Kirchhoff's junction law. And Kirchhoff's junction law says that the current coming into the junction should be equal to current going out. So what is the current coming in? It is 2 ampere and 10 ampere. So 2 plus 10 is equal to what is the current going out? It is 4 ampere and I. So this becomes 4 plus I. Hence I will be 8 ampere. And option C is going to be our answer. Alright, Tushti says easy questions till now. Yes, absolutely. These questions are very simple. So the thing we need to keep in mind is there are a lot of questions. Okay, so we have to solve all the questions, not all the questions, the number of attempts, that 20, 20 and 5 questions. So we have to attempt 45 questions, but what we have to keep in mind is the accuracy. We should not get carried away. But I'm glad that most of the people are finding it easy, which means you have studied. Alright, perfect. Let's go forward. So potentiometer is a better instrument for measuring EMF as compared to voltmeter because, so this is a theory based question and the correct answer is going to be null deflection method, option D. Okay, potentiometer works on the null deflection method, which means that the current through the external circuit is going to be 0, hence the primary circuit will not be disturbed by the external circuit. Hence we get the correct reading. Okay, so option D will be the correct option. What is next? Two resistors have their resistance in the ratio 2:3. If these two resistors are connected in parallel, then the ratio of respective power dissipated through the resistors will be equal to. Alright, let's see. The ratio of resistance is given. What is power dissipated? Power dissipated is V square by R. Now this is parallel connection, so V is going to be constant, which means power is inversely proportional to R. Can we say that? Power is going to be inversely proportional to R. So P1 by P2 will be equal to R2 by R1, and hence it is going to be equal to 3 by 2. So the correct option is going to be option A. Next question. A current is passed through a wire and the power dissipated is observed to be equal to P. Now the wire is stretched such that the length becomes double. If the same current is passed through the wire, then the power dissipated will be equal to. Okay, let's see. Now the power dissipated is I square into R. Now current is going to be the same, so it is going to depend on R. So what is resistance? Resistance is rho L by A. Now what we are doing here is we are going to multiply and divide by L. Okay, when we multiply and divide by L, we are going to get rho L square upon A into L is going to become volume. Now volume is not going to change, hence volume is a constant. So what do we see? We see that the resistance is going to be proportional to L square. And when we put it over here, we'll find that I is a constant, rho is a constant and V is a constant, which means power is proportional to L square. Now the length has become twice, which means the power is going to become 4 times, which means option C is going to be the correct option. Alright, perfect. Let's move forward. Equivalent resistance between any two adjacent corners of the square as shown in the figure is. Alright, so this is our circuit diagram and we have to find the equivalent resistance between A and B. Now what we see is this resistor and this resistor is in series. So this is going to be 3R and this 3R is in parallel with R. So all we have to do is use this. 1 upon R equivalent is equal to 1 upon R plus 1 upon 3R. When we calculate this, we are going to get 3R upon 4. Very, very straightforward question. So option D is going to be the correct option. Perfect. Most of you are getting that right. I am very happy about it. Perfect. Let's move forward. In the following circuit diagram, the potential of points A, B and C are 10 volt, 20 volt and 20 volt respectively. The potential of the junction O is, okay. So here what we'll have to apply is Kirchhoff's junction law, that the current, the net current through this coming into this junction has to be equal to the net current going out of this junction. Okay, so we can simply say whatever is the net current into the junction, the summation of that should be equal to 0. Okay, so what are we writing here? VB minus VO. Okay, so we are calculating the current coming out. So VB minus VO is the potential difference divided by the resistance is the current going out. Okay, So the current going out, I have written it for all the three branches, and all I have done is I have substituted the values of the voltages and I have substituted the values of the resistors. So if I do the calculation, I'm going to get VO is equal to 160 upon 11 volt. Okay, so that should be the answer, and option B should be the correct option. What next? Now n equal resistances are first connected in series, and the same n equal resistances are connected in parallel. The ratio of net resistance in series combination to that of parallel combination is. Okay, Arnav is asking, oh sir, will the recording be available? So if you're talking about this session, yes, it is going to be available on YouTube. If you miss something, you can always go back and watch it again. Not an issue at all. All right. So let's get back to this question. Now what do we have here? We have n resistors in series. In series, what is going to happen? They are simply going to get added up. So if I add them up, the equivalent resistance for the series combination is going to be NR. And when we have this parallel combination, then this is going to become 1 upon R EQ is equal to 1 upon R plus 1 upon R and so on. So 1 upon R EQ will become N upon R. Hence R EQ is going to be R upon N. Okay. And if we take the ratio, then obviously we're going to get N square. Okay. So option A is going to be the correct option. Let's move forward. Question number 15. The magnetic field due to a long current carrying wire at a perpendicular distance R is B. Then the magnetic field at a perpendicular distance to R will be equal to. Okay. So the magnetic field due to a long straight wire is given by B is equal to mu naught I upon 2 pi x. What is x? X is the perpendicular distance. Okay. So the magnetic field at point P1 is going to be mu naught I upon 2 pi r. This is B. And the magnetic field at a distance 2r is going to be mu naught I upon 2 pi into 2r. Okay. So this is going to become B upon 2. So what should be my correct option? Then option D should be my correct option. Okay, Anand is saying, sir, why the screen is not clear? Is it so? Is my screen visible clearly to everyone? Just let me know. Alright, I think Anand, probably you can refresh it or you can start it again. Everyone is saying that the screen is pretty clear. Okay, so just try doing refreshing it once. Alright, perfect. Next one. If a long, hollow, thin copper pipe carries a direct current, the magnetic field associated with the current will be present. What are the options? Only inside the pipe, only outside the pipe, neither inside nor outside, both inside and outside. Okay, so this is a simple question on Ampere's law. So if we take an Amperian loop inside, the current through the Amperian loop is going to be 0 because there is no current inside the conductor. And if we take a point outside, then certainly there is this current which is flowing crossing the Amperian loop. Okay, which means inside the magnetic field is going to be 0, outside the magnetic field is going to be non-zero. So what will be the correct option? The correct option is going to be option B, only outside the pipe. Perfect. Let's move forward. Magnetic declination is the angle between magnetic meridian and this is a straightforward theory based question. So the magnetic declination is the angle between the magnetic meridian and the geographical meridian. Okay, so this question should take 5 seconds to solve. So option C is going to be the correct option. Next, what do we have? The true angle of dip at a given place on Earth is equal to 53 degree. If the plane of the dip circle is at an angle of 60 degree with the magnetic meridian, then the apparent angle of dip will be, we can take tan 53 degree as 4 by 3. Now this is a slightly tricky question because when we use the dip circle, the plane of the dip circle is always in the magnetic meridian. Now if it is not in the magnetic meridian, it is making an angle 60 degree with the magnetic meridian, then what do we have to calculate? We'll have to do this manipulation. So tan delta prime is equal to tan delta upon cos phi. What is delta prime? It is the apparent dip. What is delta? It is the true dip. And phi is the angle of inclination between the plane of the dip circle and the angle it is making with the magnetic meridian. So all we need to do is do the substitution. So tan delta prime will be equal to tan 53 degree divided by cos 50 degree, and hence we are going to get 8 by 3. Alright, so option A, tan inverse 8 by 3 is going to be the right option. How many of you got this question right? Alright, what is the next question? The magnetic flux linked with the coil is given by phi is equal to 2t square plus 3t plus 1. The charge that flows through the coil in time duration t is equal to 1 second to t is equal to 4 second will be. The resistance of the coil is 4 ohm. Okay, so we have to calculate what is the charge which has flown. Okay, now the charge which has flown is going to be equal to delta phi upon r. Okay, it's a small calculation, a small manipulation you have to do. And if you do this manipulation, then delta Q, the charge flown, will come out to be delta phi upon r. Which means we have to calculate flux at 4 seconds and we have to calculate flux at 1 second, subtract it and divide it by r. Okay, so we already know flux as a function of time. Substitute it and the value you're going to get is approximately 9.75 coulomb. Okay, so option B should be the right option. Next. A straight conducting rod of length 2 meter is moving with the speed of 2 meter per second in a uniform magnetic field of magnitude 10 Tesla. The maximum induced EMF across the ends of the rod can be. Okay, now when we have a conductor moving in a magnetic field, let's say this is the conductor moving with some velocity in a magnetic field, then the maximum EMF induced is going to be when the length is perpendicular to the magnetic field is perpendicular to the velocity. Okay, so the maximum EMF is going to be induced when all these three quantities, the length, the magnetic field and velocity, are perpendicular to each other, which means that the EMF induced is going to become BVL. This is the maximum. Okay, if any of these quantities are not perpendicular, then we'll have to take components and that is going to reduce the value of either B, V or L. Okay, so the maximum EMF induced that can be possible is BVL. Okay, so we do the substitution and we get 40 volt as the correct answer. So option C is going to be the correct option. Alright, next up, magnetic flux changes through a coil of resistance 10 ohm. As a result, an induced current is developed in it, that's obvious, which varies with time as shown. The magnitude of change in magnetic flux through the coil is. So we have a graph between current and time and we have to find out what is the change in magnetic flux. Alright, so obviously what we're going to use here is Faraday's law. E is equal to minus d phi by dt. And whatever is the EMF induced, that is going to be equal to I into R. Is that correct? Okay. So d phi will be equal to I dt into R. Okay. Obviously what we are talking about here is the magnitude. Okay. We just need the magnitude of change in flux. Okay. So I have dropped the minus sign. So delta phi is going to become, so if we integrate on both sides, d phi is going to become delta phi. This will be equal to R, which is a constant. It comes out and then we have integral of I dt. Now from the IT graph, what is integral of I dt? It will be the area under the curve. Is that correct? Okay. So we are going to make the substitution here. So delta phi will be equal to 10, which is the resistance, into half into base into height, and this is going to give me 2.5 Weber as my answer. Alright, let's move forward. So option C is going to be the correct option and we can move ahead with the session. Alright, Tushti says, sir, please take next JEE Flash on magnetic chapter. That is a good idea, Tushti. I'll certainly keep that in mind. Alright, thanks for letting me know. Alright, next question. The RMS value of the current is given by I is equal to 4 sine 100 pi t ampere in a complete cycle is. Okay, we have to find out what is the RMS value of this current. Now this current is a sinusoidal function, and for a sinusoidal function we know that IRMS is going to be I naught by root 2. Okay, remember this is only for a sinusoidal function. So 4 upon root 2 is going to give me 2 root 2, and that is going to be my answer. So option B is going to be the correct option. Perfect. As the frequency of the source is increased, then the capacitive reactance, we have to tell, does it remain constant, does it increase, does it decrease, or may increase or remain constant. Okay, so the capacitive reactance is given by 1 upon omega c. Is that correct? Capacitive reactance is given by 1 upon omega c. And what is omega? Omega is 2 pi into frequency. So from this relationship, what do we get? We get that the reactance is inversely proportional to frequency. So if frequency is increased, what will happen to reactance? It is going to decrease. So option C is going to be the correct option. Next, a circular current carrying coil has a radius r. The distance of a point from the center of a coil on the axis where the magnetic induction will be 1/8 of its value at the center of the coil. Okay, so we have to find out at what value of x, which is the distance from the center along the axis, the magnetic field is going to be 1/8 of the magnetic field at this center. Alright, so first of all, what is the magnetic field at the axis? Okay, what is the magnetic field at the axis? So it is given by mu naught upon 4 pi into, so a good way of remembering it is mu naught upon 4 pi into 2 mu upon r square plus x square to the power 3 by 2. Okay, so in the numerator we have 2 mu. So what is mu? Mu is the magnetic moment. So pi r square into I is going to become the magnetic moment, and in the denominator we have r square plus x square to the power 3 by 2. Okay, so when we are talking about the center, we are going to substitute x equal to 0. So we are going to get b naught is equal to mu naught upon 4 pi into 2 pi r I divided by r. Okay, and this is a well-known result. This is mu naught. This is basically mu naught I upon 2r. This is a well-known result. Okay, now at point P, let's say this x, this distance is equal to r, small r. So when we substitute it here, we're going to write it as r square plus small r square to the power 3 by 2. Okay, now this is the magnetic field at point P. This has to be 1/8 of the magnetic field at point O. Okay, so we are going to substitute, we are going to cancel out all the terms. A lot of terms are going to get cancelled. So 2 pi I here, a lot of terms are going to get cancelled, and when you solve this, you're going to get small r is equal to root 3 capital R, and that should be our answer. So option B is going to be the correct option. Alright, next, what do we have? The current I in a coil varies with time according to the graph shown below. Which of the following graphs shows the induced EMF E in the coil with time? So we have a graph which is a graph of I versus T. We have to tell that what will be the graph for EMF with respect to time. Okay, so the EMF induced in an inductor is given by minus L di upon dt. What is di upon dt? Di upon dt is the slope of the IT curve. Okay, so for AB, di upon dt is going to be what? It is going to be 0 because it's a flat line. So the slope is 0. For BC, di upon dt is going to be negative because the slope for BC is negative. So EBC is going to be positive. Okay, the EMF induced in this case is going to be positive because of the minus sign over here. And then for CD, the slope is positive. So ECD is going to be negative. Okay, so what do we have? For AB, EMF will be 0. For BC, EMF is going to be positive. And for CD, EMF is going to be negative. So which of these graphs would be the correct graph? So we see 0, then it is positive, and then it is negative. Is that correct? So option C should be the correct option. Okay, before we proceed, if you like what we are doing, if you like the sessions we are doing, if you're finding it helpful, then do subscribe, and because we are making a lot of content that is going to be very helpful for your preparation. Okay, so if you want to stay updated with the new videos that are being released, so please subscribe to the channel. All right, let's move forward, and now we are at section B. Now section B, we're going to start here. How many questions we have to attempt? 20 out of 24. All right. A solid cone of base radius equal to r and height h is placed in a uniform electric field of magnitude E and directed parallel to the axis of the cone. Net flux through the cone would be equal to. Such a verbose question, but the answer is very simple. What is the concept here? That for a uniform electric field, the flux through a closed surface is going to be 0, because the flux coming in will be the same as flux going out. So option A is going to be the correct option. Next, when two charged particles are placed at a certain distance apart in vacuum, then the force experienced by one of the charges is equal to F. If the vacuum is replaced by a medium of dielectric constant 6, then the net force experienced by the charged particle will be equal to. Now we know this very well. We know this very well, that if we have a if the charged particles are put in a dielectric medium, then the force is reduced by a factor of the dielectric constant. So what will be the answer? Very straightforward. The answer is going to be F by 6. Absolutely. These questions are really easy, and this gives you a lot of indication of what you should expect in the board's exam. So if you are good with the concepts, if you have done decent practice, then board's exam should not be a problem at all. Alright, let's move forward. A large conducting sheet is having surface charge density sigma. Electric field at a point close to it is. Okay, now so this could be a little confusing, because if you have a non-conducting sheet, then electric field is sigma upon 2 epsilon naught. But if you have a conducting sheet, then the conducting sheet has two surfaces. Okay, so the charge is going to come to the surface, so you're going to have two surfaces. In that case, the electric field would be sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught, and that is going to give us sigma upon epsilon naught. Okay, so the correct answer is going to be option D. What do we have next? We have four charges, 2q, q, and minus q, and are placed at the corners of a square of side length A. The electrostatic potential at the center of the square will be. Okay, now this you can do it the usual way. We know that the potential is given by kq upon r. So obviously we can find the potential due to all the charges at the center and add them up. Or you can be a little smart. What can you do? So this minus q is going to have a negative potential here. This plus q is going to have a positive potential over here. And they're going to be equal in magnitude, because the charge magnitude is same, the distance is the same. So they're going to cancel each other out. Now this 2q, I can write it as q and q. So similarly, this minus q and this q is going to get eaten up by each other. Okay, so their potential is going to cancel each other out. So what do we have? We simply have the potential due to one charge. The potential due to one charge is going to be very simple. What is that going to be? It is going to be k q upon this distance, obviously is going to be a upon root 2, half the diagonal. Okay, so what will be the correct option? Option B is going to be the correct option. Alright, let's move to the next question. Now we have a parallel plate capacitor of capacitance C, and it is charged to potential V and then disconnected from the battery. The capacitor is now connected to an identical capacitor charged to a potential difference of 2V, such that the positive polarity plates are connected together. At steady state, the common potential of the capacitors will be equal to. Okay, so we have charged it, and then we have disconnected it from the battery, and the positive plates have been connected. Okay, we have to find out what will be the common potential difference. So the common potential difference is given by C1V1 plus C2V2 upon C1 plus C2. Okay, So the capacitance is same, so the capacitance will be C. The voltages would be V and 2V, and then divided by C plus C. So if we do that, we are going to get V common as 1.5 volt. That's it. So what will be the correct option? The correct option is going to be option A. Alright, what do we have next? Consider the following two statements. For charged conductors in electrostatic condition, the surface charge density is always uniform. Okay, what is the statement? For charged conductors in electrostatic condition, the surface charge density is always uniform. And the option B, or the statement B, is for a charged conductor in an electrostatic condition, the potential of the surface is always uniform. Okay, so if you have a conductor, then the surface of the conductor is, or the entire conductor is an equipotential. All the points on the conductor are going to be at the same potential. Okay, if there is a potential difference, the charge is going to flow to negate the potential difference. So all points on the conductor are going to be at the same potential, which means that the potential is going to be uniform at all points. So statement B is correct. But if the potential is the same, if the potential is the same, and we have a conductor of irregular shape, then the surface charge density cannot be the same. Okay, because the radius of curvature at different points is going to be different. So the surface charge density cannot be the same. So what will be the correct option? Option B is going to be the correct option. Only the electrostatic potential is going to be uniform, not the surface charge density. All right, let's move forward. Which among the following operations would increase the capacity of a parallel plate capacitor initially filled with air? Okay, so we have a parallel plate capacitor and it is initially filled with air. Which of these things it is going to increase the capacitance? Alright, let's see. Inserting a dielectric slab between the plates, we know that if we insert the dielectric, then the new capacitance is going to become K times the old capacitance. Is that correct? So option A, certainly. Increasing the distance between the plates, so capacitance is epsilon naught A by D. If we increase the distance, the capacitance is going to decrease. Decreasing the distance between the plates, yes. If we decrease the distance, capacitance is going to increase. So option C is going to be the correct option. So what will be the correct option, as in what will be the correct answer? It is going to be option D, both A and C. Absolutely. Let's move forward. What next do we have? We have the electric field due to a short electric dipole at a distance r from it. On its axial line is E. The electric field on its axial line at a distance r by 2 will be equal to. So we are talking about a short dipole and we are talking about the electric field at an axial point. So for a short dipole, the electric field at an axial point is given by 2 kp upon r cube. Okay, and we are changing the distance only. We are not changing anything to the charges. Okay, we are not doing anything to the charges. So P is going to remain the constant, which means that the electric field is going to be inversely proportional to r cube. Okay, so if r is reducing, r is becoming half. Okay, if r is becoming half, then electric field is going to become 2 cube times. Is that correct? So we can write E prime upon E is equal to r cube upon r by 2 cube, and that is going to give me 8. Is that correct? Okay, so if r is becoming half, then the electric field is going to become 2 to the power 3 times. Is that correct? Simple inverse proportionality relationship. Okay, Tushti says there is a doubt in question number 31. Okay, what is the doubt, Tushti? Can you tell me what is the doubt here? If you can tell me what is the doubt, then I can clarify that. Alright, so you are asking why is the charge density not the same? Okay, why is the charge density not the same? Now what we need to understand here is that the potential is same. Okay, so if we break this down, we make it very simple. So let's say the potential is given by kq upon r. Okay, I'm simplifying it to make you understand it. Okay, so the potential is given by kq upon r. So in this situation, if the potential is a constant, then what will happen? So what is charge density? So Q, we can write it as we can write it as the charge density multiplied by the area. Okay, and area is going to be, let's say we are talking about a sphere, so the area is going to be 4 pi r square. Is that correct? So if potential is a constant, if the potential is a constant, then surface charge density will be a function of r. Is that correct? Okay, so less is the radius of curvature, more is going to be the surface charge density, and if more is the radius of curvature, then less is going to be the surface charge density. Yes, Abhinav is absolutely right about his explanation. Okay, so I've simplified this to show you, but we can show that what is the electric field near, or what is the potential at a small part of the conductor. We can calculate that and show you, but I have taken a simple example of a spherical conductor and I have shown it to you. Okay, so I hope I have clarified your doubt. Let's move forward. Alright, here what do we have? We have a conducting wire having 10 to the power 29 free electrons per unit volume, and it carries a current of 20 ampere. If the cross-section area of the wire is 1 millimeter square, then the drift velocity of the electrons will be. Okay, so this is a simple question. What is the current? The current is given by NeAVD, where N is the number of electrons per unit volume, E is the electronic charge, A is the area of cross-section, and Vd is the drift velocity. So we know all the quantities. Vd will be I upon NEA. We know all the quantities, and when we substitute it, we're going to get Vd is equal to 1.25 into 10 to the power 3 minus 3 meter per second. Okay, so the correct option is going to be option B, a simple, straightforward formula based question. Let's move forward. Okay, what do we have here? We have a meter bridge experiment. So in a meter bridge experiment, the resistance in the left gap is equal to 2 ohm. So the resistor here is 2 ohm, and the bridge is divided into the ratio 1:2. Okay, so the length ratios are 1:2. What do we have to find out? We have to find out the value of resistance in the right gap. Okay, now meter bridge works on the principle of balanced Wheatstone bridge, which means that the resistance of P upon resistance of Q will be equal to L1 upon L2, because the resistances of the wire are going to be proportional to their lengths. Okay, so Rp upon Rq is equal to L1 upon L2. We know what is L1 upon L2, we know what is Rp, so we have to substitute and we'll get Rq is equal to 4 ohm. Alright, so what will be the correct option? The correct option is going to be option A. Alright, Kirchhoff's loop law is based on the conservation of. Okay, so this is a theoretical question. You should know this, that Kirchhoff's loop law is based on the conservation of energy. Okay, if we add up all the potential differences in a loop, that sums up to 0. This is a consequence of conservation of energy. So option D should be the correct option. A current of 2 ampere is flowing through a wire. The charge that would flow through the wire in 20 seconds will be. Now this is a very straightforward question. The charge flowing will be I into T. Is that correct? If a constant current is flowing, then the charge flown would be I into T. So this simply becomes option C, 40 coulomb. One of the easiest questions in this paper. What's next? For a charged particle of charge q and mass m undergoing uniform circular motion in a uniform perpendicular magnetic field B with speed v, the angular frequency of the charged particle is independent of. Okay, what do we have to find out? The angular frequency of the charged particle is independent of which of these quantities? Alright, so first of all, what is the time period of a particle doing circular motion in a uniform magnetic field? It is T is equal to 2 pi m upon qb. What is the angular frequency? Angular frequency, or we should say angular velocity in this case. This is not going to be angular frequency, this should be angular velocity. Okay, or the angular velocity and angular frequency in this case are going to be the same, so we can use it interchangeably. Okay, so but strictly speaking, this is angular velocity. So the angular velocity is going to be omega is equal to 2 pi upon time period. So from here, if we manipulate it and we figure out what is the angular velocity, we're going to get QB upon M. So what is it independent of? It is dependent on charge, magnetic field and mass, but does not depend on the speed of the particle. Is that correct? Which means that option B is going to be the right option. Alright, we're making good progress. What is the next question? A particle of charge 2 coulomb moves along a circle of radius 4 meter. The speed of the particle is constant and is equal to 2 meter per second. The magnetic moment associated with the motion of the particle is. Okay, this is a good question. Alright, so we'll discuss this in some detail. Now let's say we have a charged particle of charge Q. It is moving in a circle. So if you take any part, then in one time period, that is when it is completing one cycle, in one time period, how much charge is passing through this section? Okay, this charge Q would be passing through this section. In one time period, it will go and come back over here. So in one time period, how much charge is passing through any cross section? It is going to be Q. Is that correct? Okay. So we have the current is equal to charge upon time. So can I say current is going to be equal to the charge divided by time period? And what is time period? Time period is 2 pi by omega. And what is the area? The area is pi r square. And what is magnetic moment? Magnetic moment is I into A. So I'm going to substitute for magnetic moment over here. So this is going to become omega q upon 2 pi. I'm substituting q upon t. Okay, I'm substituting q upon t. So this is going to become omega q upon 2 pi and then multiplied by the area, which is pi r square. So we are going to get omega q r square upon 2. Now we can do a little bit of manipulation here as well. Now we know that omega is equal to v by r. So v will be equal to omega r. So this omega and this r, we can write it as v. So this is going to become qvr upon 2. And we have all these quantities supplied to us. So we know what is charge, we know what is velocity, and we know what is radius. So when we calculate that, we're going to get 8 meter square, 8 ampere meter square. So option D should be my right option. Alright, let's move forward. Now we have a moving coil galvanometer, and it can be converted in a voltmeter by connecting a large resistance in parallel, connecting a large resistance in series. Okay, now if you have studied conversion of galvanometer into an ammeter or voltmeter, we know that we have to connect this shunt, and this shunt should be a large resistance connected in series. So option B should be the right option. A long solenoid has 50 turns per meter of its length. If a current 5 ampere is passed through it, then the magnetic field at the end of the solenoid will be nearly equal to. Okay, so in case of a solenoid, if we are talking about the magnetic field at the center, then the magnetic field at the center is given by mu naught Ni. But if we are talking about the magnetic field at the end, then the magnetic field is given by mu naught Ni upon 2. So this was a slightly tricky question, but you should have this knowledge. So I'm going to substitute mu, I'm going to substitute Ni, and then divide it by 2. So that is approximately going to come to 0.16 millitesla. Okay, so option A should be the right option. Perfect. What do we have next? A charged particle of charge 2 millicoulomb has a velocity equal to 2 meter per second along the positive x-axis. If in the region there exists a uniform magnetic field of 4 Tesla directed along the negative x-axis, the magnitude of magnetic force on the charged particle is equal to. Okay, now what is the force on a charged particle, moving charged particle in the magnetic field? It is given by Q V cross B. Is that correct? Now if V is in positive direction, positive x direction, and magnetic field is along the negative x direction, what is the angle between them? The angle between them is 180 degree. So sine 180 degree is going to become 0. So the force experienced is going to be 0. Alright, so option D, 0, is going to be the correct option. The angle of dip at the equator is equal to. Okay, so this is another question on terrestrial magnetism. So the magnetic field lines are something like this. For the earth, the magnetic field lines are something like this. the magnetic field lines are going to go, let's say this is the North Pole. So geomagnetic North Pole would be here. So inside what we have, we'll have the magnet like this. Alright, so the terrestrial magnetism, if you have studied terrestrial magnetism, then we know that the magnetic field created by the magnetic field created by Earth is going to be like this. Okay, we can assume that a giant bar magnet is placed at the center. Okay, so when we are talking about the equator, here the magnetic field is going to be like this. Is that correct? And what is angle of dip? It is the angle made by the magnetic field with the horizontal. What is the horizontal? The horizontal is perpendicular or the parallel. The horizontal is going to be parallel to the surface over here. Okay, so this is going to be a tangent. The parallel surface is going to be a tangent over there. So the magnetic field and the horizontal are making an angle of 0 degree at the equator. Correct? So what will be the correct option? The correct option is going to be option A. Absolutely. Perfect. What do we have next? The negative of the slope of magnetic flux through a coil versus time graph is equal to. Alright, this is a very straightforward question. So we know that E is equal to, the EMF induced is equal to minus d phi by dt. Now what is d phi by dt? It is the slope of phi versus time graph. Is that correct? And then if we take a negative of that, then we have the EMF. Alright. So negative of the slope of magnetic flux versus time graph will be equal to what? It is simply going to be equal to the induced EMF. Okay. So option C, induced EMF, is going to be the correct option. Alright, now these questions are based on assertion and reason. So let's try to figure this out. Now, assertion reasons can get a little tricky because we don't have to just tell if these are correct or not. We also have to tell if the reason is the correct explanation of the assertion as well. Okay, so let's start. So what is the assertion? Two long parallel conductors which are carrying current in the same direction repel each other. Now this statement is certainly wrong because when we have two straight carrying conductors, current carrying conductors, if they are carrying current in the same direction, then they attract each other. They don't repel. So assertion is certainly wrong. What next? The magnetic field in the region between the conductors due to each conductor is in the same direction. Alright, so let's check that. Now for this wire, the magnetic field is going to go into the plane of the board. And for the other wire, the magnetic field is going to come out of the plane of the board. So the direction of the magnetic field is also not same, which means both assertion and reason are false. So option D is going to be the correct option. Alright, so Vasudev is saying that, sir, I feel physics is toughest. Like I'm not able to solve questions, though I know all formulas, and to be honest, I don't feel confident in physics. Alright, so Vasudev, if you're, so knowing the formula is not enough in physics, we have to be very clear with the concepts as well. Okay, so you need to understand if your concepts are there or not. So what I would suggest is, don't get bogged down by so many questions and so many material and so many things. What you should do is you should concentrate first on getting your basics right. So you pick up any basic material, you pick up any basic textbook and try to solve questions which are basic in nature. So first solve questions so that you can test your concept with that. Now if your concept is good, if you are able to solve simple conceptual questions, then go one step further. If you are able to do that, then go one step further. Okay. So if you are not feeling confident in physics, don't worry. Go back to the basics. Pick up a book which is very basic, which has questions on simple concepts. Try to first do that, and then you move ahead with difficult questions. Okay. And gradually you will get there. All right. Sir, I attend your regular lectures too. Alright, thank you Vasudev. Thanks for doing that. But that's what I'm saying. If you're attending my lectures, first go for DPPs. Okay, first try to solve DPPs. If you are able to solve the DPPs confidently, then you should be able to solve other questions as well. But first make sure that you are able to solve all the questions in the DPPs. If you are not able to solve a question, then certainly go and watch the solution, and so that you ensure that your concept is right. So the best way to do it is certainly doing the DPPs, because there you have very conceptual questions. If you are confident in that, then you go to the next step. Okay, so do this for some time and then try to go for questions which are slightly difficult. Tushti, if you are not able to solve DPPs, then certainly there is a problem with the concept. Okay, if there is a problem with a concept, then either you go back and revise your notes, or if there are specific problems that you're not able to solve in DPP, then certainly you go and watch the solution and try to understand the concept behind those questions. Alright, so let's get back to what we are doing. Okay, later I can certainly answer all your questions. But first, let's try to complete this. Alright. Question number 46, what do we have? What is the assertion? The charge flown through a cross section of wire in shape of loop of resistance R, when the magnetic flux changes by delta phi, is independent of the time in which the flux change is brought. Alright, so we'll look at this. But what is the reason? For a magnetic flux change of delta phi, the charge flown through a cross section of wire in the shape of loop of resistance R is Q is equal to delta phi upon R. So basically we need to understand what is the relationship between charge and the change in flux. Okay. Now we know that the EMF induced is delta phi by delta T. So here obviously we are talking about the average EMF induced. So this is going to be delta phi upon delta T. Now what is current? Current is going to be the EMF divided by the resistance. So the current is going to be delta phi upon R delta T. Is that correct? Now what is the charge? The charge is I delta T. From this equation, if we see what is I delta T, we'll find that Q comes out to be delta phi upon R. Now Q is equal to delta phi upon R, which means it is independent of the time. Is that correct? Okay. So both the assertion and reason are correct, and the reason is also the correct explanation of the assertion. Alright, what is next? Now given below are two statements labeled as assertion and reason. What is the assertion? When a current of I is equal to 3 root 2 sine omega t ampere flows in a wire, then the direct current ammeter connected in series reads 3 ampere. Okay, what is the reason? DC ammeter reads the amplitude of the current passing through it. Okay, so basically what is the question? What does the DC ammeter read? Okay, so DC ammeter reads the average value of the current. Okay, the DC ammeter reads the average value of current. So if current is a sinusoidal function, then obviously the average is going to be equal to 0, which means that the direct current is going to read 0. And what does it mean? It means both the assertions and reason is false. So option D is going to be the correct option. Next, given below are two statements labeled assertion and reason. Assertion is, in the purely capacitive AC circuit, average power consumed is 0. The reason is the phase difference between the current and voltage in case of a purely capacitive circuit is 90 degree. Okay, so what is the average power consumed? It is Vrms into Irms into cos phi. And what is phi? Phi is the phase difference between the voltage and current. So for a purely capacitive circuit, phase difference is going to be 90 degree. So cos 90 degree is going to be 0. Hence the average power dissipated in a purely capacitive circuit is going to be 0. So what will be the correct option? Option A is going to be the correct option, because the reason is also the right explanation of the assertion. Is that right? So option A is the correct option. Next, given below are two statements labeled as assertion and reason. Okay, so we are doing assertion and reason. What is the assertion here? The induced EMF in an ideal inductor has its magnitude proportional to the current passing through it. Okay, what is the reason? Lenz's law is based on the conservation of angular momentum. Alright, so let's see. The EMF induced in an inductor is given by minus L di by dt. So it is proportional to di by dt. It is not proportional to the current. So the assertion is wrong. Next, Lenz's law is not based on conservation of angular momentum or momentum. It is based on conservation of energy. So obviously both assertion and reasons are wrong, and option D is going to be the correct option. Alright, so we are done with section B. Section C, we have 6 questions. Let's quickly do that. Okay, so do let me know depending on how were you able to score in this paper, how confident are you feeling about your board's exam, about your term 1 exam. How confident are you feeling? Okay, based on this, the result of this mock paper you have given. Do let me know in the comment section. Alright, next, what do we have? A particle having charge Q and mass m is released from rest at origin. In a region when electric field of magnitude E, which is directed along the positive x-axis, okay, the speed of the particle as it crosses point x is equal to x naught will be, okay. So the work energy theorem tells me that the work done by the electric field will be equal to the change in kinetic energy, because that is the only force acting on it, okay. So what is the work done? Because it is a constant force, the work done is going to be force into displacement, as the displacement is in the direction of force. So the force is going to be QE multiplied by the displacement, which is x naught. This is going to be equal to half mv square, which is the initial kinetic energy, minus 0. So V will come out to be 2q Ex naught upon m and the under root of that. Okay. So option B we can say is going to be the correct option. Alright, next, consider the following 2 statements. As a charged particle is taken from a region of lower potential to a region of higher potential, its potential energy always increases. Okay, this is the first statement. What is the second statement? The potential energy of an electron-proton pair is positive. Alright, so let's explore that. So the potential energy change is going to be given by Q into V, where V is the potential difference. Now it is being taken from lower potential to higher potential, which means the change in potential is going to be positive. But it also depends on the nature of charge. If it is positive, delta U will come out to be positive. If it is negative, then the change in potential energy will come out to be negative. Okay, so we cannot say that necessarily it is going to be positive or negative. It will depend on the charge. The other thing is that the potential energy of an electron-proton pair is going to be minus k E square upon R, where E is the magnitude of electronic charge. Okay, because U is given by k Q1 Q2 upon R. Is that correct? Okay, so proton is positively charged and electron is negatively charged, so this product is always going to be negative. Okay, which means the potential energy is going to be negative. Okay, so neither statement 1 nor statement 2 are correct, so option D is going to be the correct option. Next, a series LCR circuit connected across 200 volt 60 Hz source. It consists of a capacitor of capacitive reactance 30 ohm, a non-inductive resistor of resistance 40 ohm, and an ideal inductor of inductive reactance 90 ohm as shown in the figure. The potential difference across the resistor will be nearly. So we have a series LCR circuit and we want to find out what is the potential difference across the resistor. Okay, how do we go about it? First, we should calculate what is the impedance. Impedance is given by R square plus XL minus XC square and the under root of that. Okay, Vasudev is asking a question. Sir, should I know all the derivations for JEE or just the basic idea is okay? Vasudev, the basic idea is okay. There are so many derivations. You cannot remember everything, and I don't want you to remember the derivations or learn the derivations. What you should understand is what is the basic idea behind the derivation. what are the conditions that are given, and what is the thing that we need to derive. You should have a basic idea, and more importantly, when we are doing derivations, the important thing is what are the conditions, what are the assumptions, what are the approximations under which we have done the derivation. Okay, so that is important, so that we know that under the given circumstances, in a new condition, when you are solving a question, there could be a different scenario, and then we have to be very confident that the result we are using is going to be valid here or not. So a basic idea is enough, but what the focus should be is to understand what are the assumptions and what are the approximations we have taken into account while deriving the results. Okay, that is very important. All right, getting back to this question, we can calculate what is the impedance. Once we calculate what is the impedance, IRMS is going to be VRMS upon Z. Okay, so we have all the values of R, XL and XC, so we can calculate the value of Z. Then we can calculate what is IRMS, so this is going to become VRMS upon Z. So we know what is VRMS, it is 200 volt. Then we can find what is the current. Okay, so the current is going to be 2.8 ampere, and then the RMS potential difference across the resistor is going to be IRMS into the resistance. So this is going to be 2.8 into 40. So this is going to come out to be 112 volt. Okay, so option D is going to be the correct option. All right, the situation remains exactly the same. What we need to do here is we have to find what is the value of inductance of the inductor. Okay, now the inductance of the inductor is given by XL is equal to omega L. Okay, I'm sorry, the inductive reactance, I'm so sorry, the inductive reactance is given by XL is equal to omega L. All right, so what do we know? We know what is XL and we know what is omega. So all we need to do is do the substitution. So XL is 90, which is given to us, is equal to omega is 2 pi into frequency. So this is going to become 2 pi multiplied by frequency, which is 60 hertz. It is given in the question. So from here, when we calculate L, it is going to come out to be 0.24 Henry. Is that correct? So what will be the correct option? Option C is going to be the correct option. What is the next part? Again, everything remains the same. What we have to calculate is the average power dissipated in the circuit. All right, so the average power dissipated in the circuit is given by VRMS into IRMS into cos phi. Okay, and if you remember the impedance triangle, okay, the impedance triangle, if you remember, then what do we have? We have this angle as phi, the base is R, the hypotenuse is Z, and the perpendicular is XL minus XC. Okay, so if you remember this, then cos phi is given by R upon Z. For this impedance triangle, you can say that cos phi will be R upon Z. Now we know what is the value of R. We have already calculated the value of Z. We already know what is the RMS voltage, and we already know what is IRMS. Okay, so all the values we know, we are going to substitute and we are going to get 308 watt as the answer. So option A is going to be the correct option. All right, so we are at the last question. Let's quickly get done with this. Now here again everything remains the same. What we have to do is we have to calculate what is the power dissipated across the inductor. Now the current through the inductor and the potential difference across the inductor, they are perpendicular to each other. They have a phase difference of, they have a phase difference of 90 degree, which means that cos phi for the inductor is going to be equal to 0, which means there is going to be no power dissipated in the inductor. And this is a result we should know. The power is only dissipated in the resistor, it is not dissipated in the inductor or the capacitor. Is that correct? Given that they are ideal. Alright, so option D should be the right option. Okay, so we are done with the discussion of the questions. Go back and see what are the questions you were able to solve, and if you were not able to solve the question, then why were you not able to solve the question? Was that a conceptual mistake? Then go back and revise your concept. Was that a calculation mistake? Then be more attentive when you are solving a question. Okay, don't get rushed. Take your time and solve the question. Okay, and then go back and try to analyze what are your weak areas, what are your problem areas. Is electrostatic your weak point? Is magnetism your weak point? Is AC your weak point? Go and try to figure which are the areas which are weak, and then work on them and strengthen them. Okay, so do make very good use of this mock test analysis. Alright, so Abhijit tells me happy Diwali, sir. Happy Diwali to you, Abhijit, and happy Diwali to everyone. I hope you enjoy it and be safe, both when you are celebrating a festival as well as with the COVID condition. Be safe, enjoy yourself, and I would suggest work hard, but do take a break in between so that you get recharged. You can recharge yourself and then come back to your preparation with double effort. Okay. All right. So that is it about the discussion in this session. If you want to take a trial class with Byjus classes, you can go for a free trial class. The link is in the description box. You want to figure that out, if you want to test that out, please do that. And thank you very much for attending this session, and very soon we are going to attend another session. Okay, in the comment section, do let me know what are the topics or what are the things you would like us to talk about. Okay, what are your doubts? What are the tips you need? What are your confusion? What are the questions you have? Okay, so whatever is in your mind, and if you have any suggestions for us that what kind of content we should make which is going to help you, do let us know in the comment section. Okay, so I'm going to see you very soon. Okay, so I'm sorry, before going up, I'm going to answer Abhinav. Abhinav has been asking this question. I'm sorry, Abhinav, took some time to get to you, but I'm going to ask that. I'm going to take that question. Can we have Abhinav's question? Can you share tips on how to make notes for JEE physics? Okay, Abhinav, when you're saying make notes, so basically the way to go about it. Okay, so the notes are important for revision. Okay, notes are important for revision. So when you say make notes, so physics is not a subject where you have to learn or mug it up a lot. Okay, physics is a subject where understanding is more important and the concepts are more important. So what my suggestion to everyone, and this is not related to physics, this is related to any subject. If you want to revise something efficiently, then what you should do is so when you're going back to your notes, don't just read it. Okay, don't just read it. What you should do is you should try to work it out yourself. For example, you attend a class today. Okay, and there was a concept that we learned today. There was derivations, there were questions. Okay, now make a note of those derivations, make a note of those questions, and when you go back, what you need to do is, without looking at your notes, try to derive it yourself. It would be difficult. Probably you would not be able to figure that out in the first time. But when you practice like that, when you are simply reading out your notes, it's not going to be helpful for you. So what you should do is you should try to figure it out yourself. You should try to derive it yourself. Okay, and all the questions that were solved in the class, you should try to solve them on your own, not just read it. So when you're going to solve it on your own, you're going to struggle with it, and the more you struggle with the problem, the more it is going to stick with you. Okay, I always have the habit of writing down everything. Now, so when you are attending a live class, you write down everything, not a problem. You write down everything, but later on, you make it concise. You just write the things which you need. Okay, you make a concise notes. But when you are doing it live, you can write down everything, because you don't know which part you're going to remember, which part you're going to forget. So that is fine. But later on, try to derive on your own, try to solve the questions on your own, and then make a concise notes later on. Okay, that's how you should go about the revision. Alright, so I think that's it for today, and as I said, I'm going to meet you guys very soon. Have a very happy and safe Diwali. Thank you so much for watching.